Alright, to solve this problem, I took this diagram and then broke it down into a free body diagram. I found all of the forces acting on the first block, which is just normal gravitational tension, the tension of being pulled by the second block of block 2. And then I went on to break down the gravitational force into its components. So to find the gravitational force, I just simply times the mass times the force of gravity to get me 98 newtons. And this is the perpendicular component, and this is the parallel component of the block. Well, I ended up getting left with just 49 newtons in the down direction, and T tension going in the up direction, or in the up direction, because normal force is just simply a reaction caused by the perpendicular force, or reaction to the perpendicular force, which I have written right here. So it ended up canceling out and leaving this behind. Excuse me. On block 2, there's just simply two forces acting upon it. There's a gravitational force and tension. We know that Fg, or the gravitational force, equals 98 newtons, but we still don't know the tension, and we still don't know the acceleration. So I use Newton's second law, I believe it is, to combine the forces. Well, we know that A1 and A2 have to be the same because of the way the laws of tension work. They both pull on each other, so therefore they must have the same tension or acceleration, because they're bound together by the rope. So I simply put these two equations together, these two right here, and turned it into T2 equals 147 divided both sides by 2 to get that the tension equals 73.5 newtons. So now that I figured out the tension for this problem, I went and plugged this back into the equation in order to find acceleration. So 73.5 minus 49 equals 24.5. Divided this 10.8, not 10.8, 10a into 24.5 to get that the acceleration is 2.45 meters per second squared. And that's how I solved that problem.